Excuse me. So to start off with, we're going to look at quadratic functions and the graphs of them primarily. Okay, I'm going to go over the first part of this kind of quick because there's a lot of notes out of your book that it does talk about, but in reality, you've done this stuff before. Quadratic, what is it? What's it look like if you graph it? Parabola. Okay, general form of it's that ax squared plus bx plus c. Okay, most of the stuff at the very beginning here is going to be review. The idea of this parabola, if you have a is positive, what's going to be true about it?
It opens up.
If a is negative, opens down. What does the c value tell you? Yeah, the y-intercept. How far up or down it is on the y-axis, where it is. Okay, now, that's the problem here, is that it's a little bit limited in what it tells you. It tells you which direction it opens, and it tells you where the y-intercept is. Okay? The thing is, the most useful piece of information is usually the vertex. Either the max or the min, right? The x-intercepts are good as well. Now, that vertex, though, this form doesn't explicitly tell you. You need to do some manipulation on it to get there. This does also, the vertex, if you know it, you can very easily get the axis of symmetry, though. Because it's just x equals whatever the x value is, the vertical line. Because we're sticking to a function format, the parabola is only going to be either opening up or down. Okay? So as soon as I make it a non-function, or as soon as I make it open left or right, can it be a function anymore? No. Okay, so we already talked about this a little bit. If a is positive, opens up. A is negative, opens down. Simplest type is just y equals x squared with a single coefficient in front. Okay. Graphically, if it opens up, does it have a max or a min? Min. Relative min. If it opens down, the other. So if I look at these two graphs and compare them, okay. So if I have x squared and 1/3 x squared, so I have x squared here, 1/3 x squared. What type of transformation is going on? Vertical shrink, vertical compression. Okay, it's flattening out. The nice thing about that general form, the number out front is always going to be vertical affecting it, that a value. So if it's a fraction, 1/3, it's going to compress vertically. If it's a number like 2x squared, it's going to do what? Stretch vertically, expand vertically, which will narrow it out. So going from just x squared here to 2x squared, it'll get narrower and taller. Okay? Now, this is a form where we're going to be manipulating quite a bit. This form, they call standard form. Honestly, that's kind of annoying to me because general and standard, well, they kind of have the same meaning in general. But this I usually refer to as vertex form because it hands you the vertex, HK. If you get into this form, HK is given to you explicitly. Okay? Sometimes getting into this form is easy, sometimes not. We'll get into it. So you have the two forms, the general form and the standard or vertex form, however you want to call it. A value is the same, and it gives you that vertex value. So, if I'm looking at these three functions, I want to graph them all on the same axis. Now, I'm going to do a rough sketch, so I'm not going to bother with the calculator because I can get a rough idea of these because I know what f of x looks like. It's just regular parabola. Okay? Now, compared to that f of x, what would h of x look like?
Open down into compression.
H of x. It's a vertical stretch, so it's going to be narrower than regular x squared. And because it's rising faster, and it also opens up. So that's your g of x. What about h of x?
L is h of x.
Or the, I blame Paul. H of x there, then?
And then g of x will open down and the y.
Yeah, that's the one that opens down and is very compressed vertically. Okay. Now, if I want to find the vertex of this, now remember, vertex form is y equals a times x minus h squared plus k. Now this function has both an x squared and an x, has a quadratic and a linear part. I want to change it just so I have something in parentheses squared. Okay? Well, first off, what's something I could do to this to eliminate
Factor.
the x squared part? Yeah, factor it. Okay? If I factor this down, what's it going to turn into?
X minus 5 minus 5.
X minus 5 and again x minus 5. Okay? To have one of each, it'd have to be the x squared minus 25. So this then I can rewrite as x minus 5 squared. Clean it up a little bit. Well, what would h be? Okay? 0. So literally your vertex is just 5, 0. What would the axis of symmetry be?
Y-axis.
X is equal to whatever the x value is here. Because the idea, this 5, 0 means it's shifted over 5 units. 5 units to the right. So if I move it over 5 units, that means the axis symmetry, which was the y-axis, also moves 5 units.
I
Yeah.
don't get how you determine where the vertex is.
Because if I look at this is that h and k value is the vertex. Right? Well, h is the 5 in here, because it's minus h, that's minus 5.
Oh, I see it.
And since I'm adding nothing to it, 0 is your k value.
Okay.
So this is what it's looking for that. So if I rough sketch this thing, so I'm going to go 5 to the right. Which way is it open? Up. What's its y-intercept? 25. That's this value up here. Remember, that's where it's going to intersect the y-axis. So if I go up here, just rough sketch it. Would look roughly like that. Okay. Now, that's one where they give you a nice one that factors into something that gives you the vertex easily. They're not always that nice. If I have this one, okay? Now, I can try factoring it at first, and it will give me something. What would this factor into? You have 3 and 7.
-7
No, both.
Careful. Both have to be negative or both have to be positive, right? What do you notice about the x's, though?
Never mind.
Yeah. To get negative x squared, you're going to have one x and one negative x. So this one's a little bit weird if you're trying to factor it. But once I have that, this, if I multiply this through, if I make both these positive, negative 3x plus 7x, well, that's 4x. That didn't quite work. So what do I have to do? Well, I don't want to do negative, negative. I'm actually, if the number is right, except, yeah, I'm just going to swap their positions in this case. Negative 7 plus 3x. Yeah. Now that gives me something, but it doesn't give me the vertex. They're asking for the vertex here. What does that actually give me? Where at? That's a plus.
Okay.
That doesn't give me the vertex, but what does it give me?
2, 4.
The x-intercepts. I just need to set it equal to what? 0. So I'm going to take x plus 7 is equal to 0, and negative x plus 3 is equal to 0. So that gives me x is equal to and 3. So those are the two x-intercepts. I don't quite have the vertex yet, but that's something. For the vertex, we're going to have to do another type of manipulation. Okay, so I'm going to stop that one there, then go back to what we started with. Now, for this, what I want to look at, I have negative x squared minus 4x plus 21. There is a method for doing this where you basically change the parts of this to be more like this one. This is what's called a perfect square trinomial. Because it's a binomial squared, gives you that. Okay? Now there's a process that starts with a C, has to do with squares.
Complex.
Not quite. Remember doing completing the square? This is where you manipulate the pieces so it looks exact. So this completed square up here, this perfect square trinomial, is part of your polynomial. So what I'm going to do, Okay, I'm going to separate variables from the parts without variables. So I have negative x squared minus 4x. And I'm going to put the plus 21 over here. Now, the thing is, for this to work, I'm going to group these together. I need to take out anything in front of the x squared. I need it to be a positive 1 there. So what do I take out? Negative 1. So I'm going to take a negative out, and that's going to leave me with x squared plus 4x. Now, I'm going to add a blank in here, because I need to pick a number that makes this a perfect square trinomial. But if I'm adding something inside this parentheses, I got to do something to it outside as well to compensate, because I can't change the value overall of this side of the function. And then I still have plus 21. Okay? Does anybody remember what would need to go in here?
Okay.
Go ahead.
Which math did we learn this in?
FS&T last year we did it. Okay? Plus, I don't honestly know, you probably touched on it at some point, but it's one of those things you don't spend a whole lot of time on. Okay? You'll use it more and more as you go. For this, anybody remember how I find that value? Nobody.
B over 2 squared.
Exactly. I'm going to take this b value. What goes in here is b over 2, and then I'm going to square it. That's what goes in here. So, yep, it'll be 4. Now, the thing is, I need to compensate for that on the outside. So right here, what would I need to do?
Negative 4.
Say again?
Negative 4 because the negative up front is...
Well, the negative here does make this negative, right? So I'm really subtracting 4. But I need to do the opposite of that to make it not count. So I need to add 4 out here. Whatever I'm doing inside of these parentheses is affected by what's out front. Since this negative's here, that means I'm in reality subtracting 4 from this entire side. To compensate for that, I also need to add 4. Okay? So then that allows me to manipulate this a little bit. I have a negative out there. I'm going to rewrite this as what in parentheses? X plus 2. And then plus 25 on the outside. And this gives you down to that vertex form. So what's the vertex? Careful. Negative 2, 25. Okay? What would the axis of symmetry be? X equals negative 2. If you just write negative 2, I'm counting it wrong, because it's actually describing a line. X equals negative 2. So then if I go to graph this, well, which way is it open? Down. The vertex is in negative 2 and up 25. Let's call that there. What points does it hit?
7.
0, 21.
Negative 7.
Negative, yeah, 0, 21 it'll hit, so about there. 3 it'll hit, and negative 7. So that gives you a pretty good idea of what it looks like. Questions on that? It's one of those things you just got to practice a bit for the completing the square stuff. Not right now. I want you to do a few of them out of the book. Okay. Now for this vertex form stuff. Standard form's what the book's going to call it, right? Well, if I'm given the vertex and a point the graph's going through, how can I use that to figure out the actual vertex form of the equation? Any ideas? Now remember, I'm looking at the vertex form. Yeah, you have an h and k, so plug them in. Y equals a times x minus negative 4 makes plus 4.
Oh, and you have an extra y.
And you have an x and a y, so plug those in. So I have 15 is equal to a times negative 6 plus 4 squared plus 11. Simplify it. What do I get for a coefficient on the a? In other words, what's this?
4.
Say again?
4.
4. So you get negative 2 squared, which is just 4, plus 11. So you get a is equal to
1.
1. Okay. So then, go back to the equation. Plug that in for a.
-6 plus 4 squared.
So that's negative 2, and the square of negative 2 gives you 4. Okay. Go ahead and do the next one. So what did you get for a?
No, A was 36, isn't it?
Your final a form is the number that goes in here.
Yeah.
Not quite.
2 plus 4
What?
is 6 squared.
1/4. The problem is you're not doing the whole thing if you just stop at the 36. It's 20 equals
Oh, but you said what was A value?
a. A is the number right
Yeah.
here, right?
Yeah.
Yeah, so you end up with 2 plus 4 squared. So you have 36.
Plus 1.
Subtract the 11 gives you 9. 9 divided by 36 gives you 1/4. Okay. One more thing. There is a way to find the vertex from that's general form, the ax squared plus bx plus c. Okay? But sometimes you will be asked specifically for that vertex form. You actually do need to be able to figure that out. You will also be asked to solve by completing the square. So make sure you know how to do it. Or change by completing the square. For this, if I have the ax squared plus bx plus c, I can actually just take negative b over 2a. That'll give me the x part of the vertex. Then use that, plug it in to the function to get the y value. You can find the vertex this way. Okay? This is just talking about whether it's a max or a min. Well, that's just whether it opens up or down. So, if I have a situation like this. The height, y, and feet of a ball thrown by a child is given by this function. X is the horizontal distance in feet from where the ball is thrown. How high is the ball when it is at its maximum height? Well, rather than change this to the vertex form, because it's not asking me that question, it's just asking me where the max is. Well, I can find the coordinates of the max. That just is negative b over 2a, and then plug that value in. So if I do this, what's the b value? 1, so I have negative b over, what's the a value? Negative 1/8. Simplify this a little bit, I get negative 1 over what? Negative 1/4. Negative over negative goes away. What's 1 divided by 1/4? 4. Okay? So you take 4 and then do what with it?
Plug it in.
Plug it into the function. F of 4 is equal to negative 1/8 times 4 squared plus 4 plus 4. So what's negative 1/8 of 16? Negative 2 plus 8? 6. So, how high is the max height of the ball? The coordinate of the vertex is 4, 6.
6 feet.
So the height is just the 6 feet. So the idea is some little kid is throwing a ball 4 feet away from it, it reaches its peak at 6 feet off the ground. Yeah.
If this was, let's say this question was on a test or quiz, since it doesn't specify how you need to solve it, could you plug in into your calculator and solve for min or max?
Yeah, you can do it though, if it doesn't say.
Yeah. It doesn't
But you also
specify.
need to explain how you did it.
Yeah.
Because if you just have 6 feet written and nothing else, I'm not giving you any credit for it. Okay? But yeah, this way I did it, honestly I did it this way just because it's the new way we're doing it. Questions on any of it? Okay.